This lesson is section 9.3 in the book. It is entitled Rotations. There are three types of rotations that we are going to study in this section. Technically, you can rotate an object any number of degrees in either direction. You can rotate clockwise or counterclockwise. We are going to simply focus on three of the more commonly used rotations: a 90-degree clockwise rotation, a 90-degree counterclockwise rotation, and a 180-degree rotation around the origin. The rules follow just like the rules do for reflections and translations. You start by writing the fact that you are using x and y coordinates and that they are moving in the form that y does something and x does something. Okay? In the case of 90-degree clockwise rotations, the x and y become y negative x, which means the y value slides over into the x position, and the x position slides over into the y position, but becomes its opposite value. When you rotate 90 degrees counterclockwise, the opposite happens. The x slides over into the y position, and the y position slides over into the x position, but becomes opposite. And the last one, when you rotate 180 degrees, technically that's a composition. That's either rotating 90 degrees twice or rotating 90 degrees counterclockwise twice. Either way, if you did this one twice or if you did this one twice, you would end up with this as your rule. X and y end up staying where they belong, but they just both become their opposite values. Which would make sense. If you rotate something 180 degrees, that means you're making it go in completely the opposite direction. So the x value becomes its complete opposite, and the y value becomes its complete opposite. We will look at an example of each one of these individually. This example is the 90-degree clockwise rotation. So again, the rule is that x slides into the y position but becomes opposite. The y slides into the x position and stays the same. So this is how you graph the figure using a 90-degree clockwise rotation. If I start with this object, I start with triangle ABC, where A is at coordinate 1, 3, B's coordinates are 4, 1, and C's coordinates are 5, 4. If I plug them into the rule, 1 and 3, again, my rule is that y slides into x, so my y value will become my x value, and my x value will slide into my y value, but it becomes its opposite. Okay, so y becomes x becomes y, only opposite. So the point 1, 3, which is A, would become, on the graph, would become the point 3, negative 1. So this would be point A prime. Same thing, 4, 1, point B is at 4, 1. When I slide those in, again, the y becomes x, and the x becomes my y, only opposite. So I would go and I would plot the point 1, negative 4, and this would be point B prime. I would do the last coordinate, which is C. My y coordinate becomes my x coordinate. My x coordinate becomes its opposite and slides into the y. So C becomes, instead of being at 5, 4, goes to 4, negative 5. So C prime would be back here. And so if I connect those, you can see that this object rotated down into the next quadrant, which would be a 90-degree rotation, and it went right around the origin. That's what a 90-degree clockwise rotation looks like around the origin. An example for the 90-degree counterclockwise rotation does the exact same thing. I plot my 4 points. They are 3, 3, 4, 7, negative 3, 4, and negative 2, 6, When I use the rule for a 90 degrees clockwise rotation, that means it's going to go 90 degrees this way. Counterclockwise is this way. So the rule is that my x slides into my y, and my y becomes my x, only opposite. So my x becomes my y, and my y becomes my x, only opposite. So 3, 3 would become negative 3, 3. That would be this one. That would become A prime. B is at 4, 7. B goes to negative 7, 4. My x becomes my y becomes opposite. So it would go to negative 7, positive 4. Next, negative 3, 4 is C. And when it moves, the x goes into my y becomes the x, only negative. It becomes negative 4, negative 3. And last, D, when I change that using the rules, the rule of x becomes y and y becomes x, only opposite, goes to negative 6, negative 2. If I were to connect these then, you can see that this object rotated 90 degrees, which was 1 quadrant over, and it stayed right the same distance from the origin. 180 degree rotation works the same way. You follow the rules, x becomes opposite, y becomes opposite. I'm using the point 1, 0, 2, negative 5, 5, negative 2. 1, 0 becomes negative 1, 0. 2, 5, 2, negative 5 would become the opposite of each, negative 2, positive 5. And the third one, 5, negative 2, would become negative 5, positive 2. So if I connect those, you can see that this is a 180 degree rotation, that each one of these coordinates points, this one goes to this one. Notice that they make a straight line in between them, a straight line being 180 degrees. You can look at the individual points and get the ruling for them. Okay, this one, if you look at what happens between the original and its image, you can kind of tell, okay, the prime ones are the second ones, so that means it went clockwise. Oops. You can see that it went clockwise, and our only options are 90 or 180. So it either only made a 90 degree turn, which means it only moved 1 quadrant, or it moved 180, so it would have gone all the way to the other side. From C to C prime, you can see that it only moved 1 quadrant. But from the coordinates, you can also see that the y slid into the x and that the x became its opposite. The rule for clockwise rotation, if it lets me go back, the rule for the rotation for a 90 degree clockwise rotation is that your x and y move to, that your y becomes your x, there it goes, that your y becomes your x and that your x becomes its opposite. So the rule for this one tells you that it would be a 90 degrees clockwise rotation. That is the end of this lesson. Your homework is as follows.